Ever felt interviews are like playing 20 questions with a sphinx speaking only buzzwords? Welcome back, future data overlords, because today we're tackling those vague data science questions that make you question your life choices. But fear not, because today we're exposing the unfiltered truths behind answering these seemingly simple yet deviously complex queries. Question 1, how do you actually build a model? The dirty little secret, it's less about magical algorithms and more about disciplined iteration. Step 1, define the problem. Seriously, what are we even trying to accomplish here? Step 2, data exploration and feature engineering. Dive into data exploration like a detective who just found a suspiciously clean spreadsheet. This informs your feature engineering, which is really just a fancy term for making your data less useless. Step 3, model selection, training, and validation. Then, and only then, do you get to play with model selection, training, and validation. Always, and I mean always, use robust validation techniques. Unless you enjoy explaining why your groundbreaking model is just generating random numbers in production. Step 4, deploy and monitor. Because a model isn't truly successful until it's out there, breaking things, and being continuously babysat for performance drift. Welcome to the real world, folks.
Welcome to hell.
Next up, what metrics would you look at to evaluate success? The classic. The only truthful answer is, and I quote, "It depends." Context is king. Anyone who gives you a definitive metric without knowing the context is either selling something or hasn't built a model that actually matters. Metrics for classification, accuracy. Simple but misleading if classes are imbalanced. Don't fall for the 99% accurate on a 99% imbalanced dataset trap. Precision and recall. Are you okay with false positives, precision, or false negatives, recall? The answer determines your focus. F1 score. The harmonized mean of precision and recall. A good all-rounder, but still context-dependent. ROC-AUC. How well your model distinguishes between classes. Because sometimes you just need to know how good your model is at not being wrong. Metrics for regression. MAE. Mean absolute error. Easy to understand, punishes larger errors linearly. MSE. Mean squared error. RMSE. Root. Mean squared error. Punishes larger errors more severely. Great for when big mistakes are really bad. R squared. Explains the proportion of variance in the dependent variable that's predictable from the independent variables. Basically, how much better is your model than just guessing the average? Question 3, how would you handle missing data? The age-old question. This is usually asked right after you've spent 3 days cleaning a dataset that looks like it was created by a very confused octopus. First rule, understand why it's missing. Is it just shy? Did someone forget to hit save? Or is it strategically absent, hiding a terrible secret? Simple imputation methods. Mean, median, or mode are like putting a band-aid on a bullet wound. It looks fixed, but you're probably distorting your entire distribution. More sophisticated techniques. Predictive imputation. Basically telling another model, hey, figure out what went wrong here. Flagging missing values. Sometimes the absence of data is the data. Flag it as a new feature. It's a delicate dance between preserving data and introducing bias. My personal favorite. Let's be honest, sometimes the best strategy is to just delete the entire row and pretend you never saw it. Nobody's perfect, especially not your data. Admit it. Question 4, how do you decide between different algorithms? The perennial debate of algorithm choice. Again, context is king. But let's be real. Sometimes it's just picking the fancy new one you saw on Twitter. Key considerations. Problem type. What are you actually solving? Classification, regression, clustering, or just trying to impress your boss? Data personality. What's your data's personality? Is it linear, non-linear, high-dimensional, or just screaming for a hug? Interpretability versus power. For interpretability, linear models or decision trees are your comfort food. They're transparent. For pure predictive power, where interpretability is just a suggestion, ensembles like random forests or gradient boosting or even deep learning are the reigning monarchs. Practical truths. Just remember, a complex model is powerful, but a slow model is a paperweight. And the bias-variance trade-off, it's not a trade-off, it's a philosophical debate that ends with you picking what works and hoping for the best. Start simple, iterate, and if all else fails, blame the data. There it is. Answering vague data science questions isn't about a definitive answer. It's about showcasing your systematic thinking, asking the right clarifying questions, and your understanding of brutal trade-offs involved in every decision. Keep learning, keep experimenting, and for heaven's sake, keep questioning everything. Thanks for watching, and try not to break production on your way out.
I think you closed the door too hard.